Okay, this is part 2 of the Motorola 68L11, and I have a confession to make. I did not record some of my diagnostic work on this. So what I'm going to do is try to summarize what I did to track down what is wrong with this. And starting with the old use the second AM radio test, because one of the things I want to know is the oscillator in this radio working? So the way you find that out is you take a second radio and you check to see if it does this. Now listen. So you can hear that howl. And if you move it, you can hear this radio start to work again. So this radio is only getting signal from here now. It's not getting the radio station or the noise that it normally gets, because this oscillator is interfering with this oscillator. But the minute I get out of that range where the two are fighting each other, this radio starts playing again. So when I checked this radio out, I didn't have that. It wasn't happening. So so that was a pretty good clue that, well, at that point I knew that the oscillator wasn't working. The question was, why was the oscillator not working? And there's something rather intriguing. Well, before I get ahead of myself, let me show you. Oops. Let's do not take out that speaker, please. Alright, so this first tube here is the RF tube, the first one in the chain. And I think we need more light. Maybe? Yeah, I guess so. This is the plate of that tube. So one of the things I did was, after I tested using the radio, I wanted to see what kind of signal I could get through the radio, if anything. So I hooked up my signal generator, set it to 455 kilohertz. And I was actually able to hear the 455 kilohertz coming out of the speaker, and I was able to trace it with my signal tracer. I actually only got about this far when I was tracing it, because once I got past this tube, this is the oscillator tube, this is the oscillator coil, by the way, the signal got really weak. So I knew something wasn't good. So the next thing I did was, I knew where our local station should be. So I tuned this radio using the dial, and then I used my signal tracer hooked up to this tube to find out when this radio was tuned to that station. And then I moved down the chain, and again I lost the signal in this area right after this oscillator tube. So I have 3 tests that tell me the oscillator isn't working. So the problem I've got is, why is it not working? So what really saved me was I found a schematic that actually had the voltages for this radio. By the way, be careful with these things, because when you get into this section of the tube, which this is the, I'm going to zoom in a little bit here. Get out of here. Alright. This IR5 is the oscillator modulator tube. A good portion of what the schematic is showing you here is fiction. Thankfully, it wasn't all fiction. And let's see, I'm going to zoom back out. Hopefully you can see. This is the oscillator coil down here. This is pin 4 from the tube. It goes down here and it goes into this really funky coil. Now, when I started checking voltages on this, I discovered that this pin 4 of this tube was 0 volts. And there was another, I think pin 3 was a bit low on voltage too. So I knew something wasn't right, but I still wasn't sure about, I just wasn't clear about what could possibly be wrong. And what makes this very challenging, you've got this coil, you've got two ends you can put a meter across it. You can tell if the coil's okay. You've got this coil, again, two ends you can put a meter across, you can check to see if it's okay. This coil, no you can't. This coil does not have an end that you can get to and check, is this coil complete? I said, well, this is fun. So, and you know, I think part of me was trying to deny the fact that maybe there was a problem with the oscillator coil, because if this thing was really damaged, and the damage was inside where I couldn't get to it, this radio was never going to work again, because finding one of these, it's just, you're not going to do it. Unless you could find another badly damaged radio you could steal this coil from. Because there's no information on these. There's nothing to tell you how many winds, which way they're wound, nothing. So I suppose you could try unwinding one, but again, I'm not sure I want to try that. So there was part of my mind was trying to deny the fact that, you know, something was broken here, but I finally had to admit, okay, after checking everything else out, I went back and checked the tube, the IR5, or the 1R5 rather. I checked the tube again, and the tube was fine. It checked out well on the tube tester. So I went back to this and started checking this out again. I need to mention that this part is being filmed after I did the repairs to this. So what I'm going to do is I'm going to show you a short clip where I show what I found, what the problem is. Then the next one will be looking at the repair and testing the repair. And we'll go from there. There's a very fine wire right there, and unfortunately that wire is floating loose right there. I just touched it and it departed. Okay, well, I think I've got it. I don't know. What I did was I took a piece of a single strand from a wire, and let's see where we are. And I managed to solder these two pieces together. I'm hoping that's something that will last. I'm tempted to put some silicone on there to keep it from corroding or anything. But this is how I decided to test it. I've got my signal generator connected here, my oscilloscope, except that you can't see it. I got to remember when I do things. All right. So I've got my signal generator attached. I got my oscilloscope, and if I go here, see that? I go to this coil. You can see that one. Let's brighten this up a little bit. Okay, it's better. So this is a single coil that I've jumped across, and there's a coil that goes between here and here. And then this is the wire that I just repaired. So if I go to this one, you see I I can read some activity there, and then I put this one here, and you can read some activity there. So I think this coil is repaired. I didn't know how else to test this other than putting it back in the radio. So anyway, I think I am going to put a little bit of silicone on there just because I don't know if it's going to And if it broke once before because of corrosion or something, then there's a chance that it might fail again. I don't know. But yeah, I should be able to do that without harming anything. I've got the silicone too. Silicone. Okay, there's one final bit that I wanted to put in here that I'd forgotten to mention. The leads and the wires, you'll probably notice, just go straight into this little tab. They aren't bent around the tab like you would normally see on the tube socket. This is how the factory did it. And there's a very good reason for them to do it that way, because these tabs and this coil are very, very fragile. In fact, I think this one down here actually wiggles a little bit. I'm not going to play with it. If you were to do the usual, put the wire in and loop it around and solder it, and then you had to replace a component, you run a very, very big risk of damaging the coil, breaking the tab off or something, or breaking the little fine wire that goes to the tab. So if you're working on something like this and you see that the factory has just stuck the wire straight through and soldered them, don't try to improve on what they did, because there's a reason for it. They're trying to make it possible to service the components that are connected to this without breaking the coil. At least that's my conclusion based on what I'm seeing, because there's nowhere else in the radio where they do that. So just a word to the wise, just be careful. Pay attention to how the factory did things. There's a reason for them doing that. So I thought I would just mention that. I forgot to put it in, so this little segment I'm adding. Okay, well, I am back, and as you can hear, 67. That's our local station. This radio actually works better than the little Zenith that I had. So, yes, that oscillator coil with a broken wire, that broken wire was my issue. Okay, now that the radio is working, I started checking some other things out, and well, I ran into some things, and fortunately I'm part of a radio club, vintage radio club, and I got some help from them. But here's the mistake I made. You notice this mess up here. I had this all neatly put together. I had bought a 200 ohm or a 200 ohm high watt, 10 watt resistor. This all neatly put together. But I was ignoring something that was rather important. And part of it comes from the fact that, well, I'll be honest, I was just ignoring something I shouldn't have ignored. I checked the voltages. I finally did find a schematic that gave me some voltages, but one thing they did not give me was the filament voltages for the tubes, but I can get those from a tube manual, and I did. And these are supposed to be, let me just check. 1S5, I know, is one of my tubes. I'm pretty sure they're supposed to be 1.4 volts, and that's what they are. So, that's not what I have. And I kind of ignored that, because these were down around 1 volt, 0.9, at one point I was seeing 0.8. Of course, some of that depends on where I've got my isolation transformer set, of course. But this was still too low, because my plate voltage was pretty close to where it was supposed to be. So here's why this is a mistake. I had gone through the trouble of figuring this out, or thought I had figured this out, but I hadn't dealt with the fact that this thing was not right. Because when I checked out, when I found out that this was, the filament voltage was low, And once I got the radio actually working properly, then I started exploring um, the voltages, because that was the next thing I wanted to know. Did I have the voltages set correctly? Were they right? Because in order for a radio to work properly, the voltages do have to be correct. And by the way, filament voltage is really important. It definitely has a big impact on how the radio works. On some of the very, very early radios, they actually used or adjusted the filament voltage to control the volume of the radio. So at the very least, you could wind up with low volume, but it also probably affects other things as well. Other performance issues could crop up if you have low filament voltage. So I was a little bit puzzled at first, because once again, I didn't look through my schematic carefully enough. I didn't examine it to see exactly what they were doing and how. I guess this also shows my lack of experience, but anyway. But once I traced it out, it made sense to me, and I started realizing, oh, this is where my problem is. This resistor here is this mess up here. It was originally 150. This resistor is measuring 160, and I don't know if you can see, but this thing has started to corrode. These sand resistors are known for this, and I've seen them where they've corroded so badly where the sand material is actually flaked off, because there's a metal band that wraps around these, and I've actually seen where the corrosion on the metal band got enough that it forced the sand material off the resistor. These are not great resistors. This one's already starting the process of failing. It's, like I said, it's right reading 160. Eventually, it's just going to get worse and worse and really go bad. So that's not usable anymore. But anyway, I digress. All right, so right now I've got about 190 ohms right here. And I did all this because I thought that maybe the 200 ohm I had in there was too high a resistance, and I needed to bring it back down. This mess was the best I could do with the resistors I have on hand. It definitely tells me that I need to order a better range of high watt resistors, because I'm probably going to need them, especially if I keep playing with these battery powered radios. But anyway, so right now that's about 190 ohms. And, I would expect, 30 to 40 ohm difference between what originally was there and what you need with a silicon diode. That's roughly where I start when I'm examining or trying to discover what resistance I need to use to replace the original resistance when I'm doing something like this. Whether it's a tube rectifier or a selenium rectifier, which is what I took out of here, the resistance has to be higher because the voltage will be too high if you don't do that. So anyway, the reason I'm into this mess, having ordered apparently the wrong size resistors, is because I ignored this. Let me show you. Alright, I have wandered too far afield, and alright, so this controls all the voltages coming into the set. And it splits here. This is the plate voltage heading out through this 820. This part goes to the filament voltages. And you see 2060. Well, this is a center tap resistor, and one side of it is 1030, and the other side is 1030. So what they've done is they've got a pi circuit here, and this half of the resistor, the 1030, connects this capacitor with that one, which is the pi filter circuit. And then the other side of this adds the additional resistance that's necessary to make sure the filament voltages are correct. Now, this resistor, when it's cold, reads about 1500 on this side and about 1200 on this side. So it's almost 700 ohms out of whack, which is bad, which is why my filament voltages are too low. I wish I had taken the time to figure this out first, because this and this work together. if this is working right, it actually has an impact on this voltage right here. You increase the voltage going to your tubes, they're probably going to draw more current, which would make sense. There's going to be a bigger voltage drop across here. This voltage drops. So both of these, you've got to work with these together, and the starting point should have been this. Knowing that this was out of spec, I should have gotten the resistances to replace it, and I didn't. I talked to one of the guys in the radio club, and they said, you know, these can-ohm resistors, junk, get rid of them, they're just nothing but trouble. They're simply pressed, the connections are simply pressed against the wires, the wire wound resistances. They fail, they make bad connections, and this one, when it's cold, it's about 1500 ohms. When it gets warm, it gets somewhere close to what its resistance should be if you measure it right after you turn the radio off. But it's still not right, and the filament voltages, even when this resistor is warm, are not correct. I actually, because I'm trying to learn things, I'm experimenting, I'm trying to figure things out. So I took an 8K ohm and jumped across here, and another one that was slightly higher. It's probably close to 9K, because that's all I had. The end result was that by jumping this, putting a resistor in parallel with this and in parallel with this, both of these halves were then measuring about what they should have been. They were very close. So then I fired up the radio with this setup in place, and now I'm seeing 1.2, 1.3 volts. So, and I'm not, okay. So I'm betting that once I get the new resistors I ordered are 1K ohm resistors. I decided not to worry about the fact that it's going to be about 60 ohms less. Because what I'm going to do, because the pi circuit doesn't really care. I mean, 30 ohms one way or the other for the pi circuit, the filter circuit, it's not going to matter. It will not care. And I'll check the voltage here, but I'm pretty certain that the voltage here is going to be relatively low, and like I said, it's not going to matter. What will matter is what voltage I get on my filaments. So when I get my new resistors, this comes out, I put the new resistors in, I'll crank my isolation transformer down a little bit, check my filament voltages, bring it up to where I think they're where they should be. And if I can get it up to full voltage and they're happy, and my plate voltage is happy, then I'll be all set. I'll be all done. But my starting point is this. So I'm going to put new resistors in here when they come. They're on order. Hopefully I put those in. End of the problem. Everything will be fine. But I will have to try this with my 200 ohm, because this mess can't stay. I'm not going to. There's no way in the world I'm leaving that disaster in there. That's just not going to happen. So, I'm yammering on. So, what have I learned? Check the resistances, especially the high power resistances in your power supply. And don't ignore potential problems, because it will come back to bite you, as this has. So, I hope I've learned my lesson, and going forward, I will pay more attention to this. So, I'll get the new parts in, I'll check my voltages, I will do a final alignment on this, and then I'll show you how this is working. Okay, before I get to doing my alignment, I wanted to show you what I wound up doing, what I found. The new resistors are in. I finished putting the other new components in that were needed. I actually wound up going back to the 200 ohm resistor that I originally had there, because I'm hoping you can see that clearly enough. This is the plate voltage between two of the tubes, or on one of the tubes. I think, is this a plate? Yeah. They say the schematic said 95 volts. I'm getting 97 volts, and that's with the 200 ohm resistor. And if you remember right, let's see here. The primary load resistor, that's the 200 now, not the 150. I replaced that. Feeds everything into the radio. Part goes to the plate, part goes to the filaments. So the plate voltage, even with a 200 ohm resistor in there, is actually just a little bit high, not horrible. And then when I check the voltage here, 107, 108, that's reasonable. And then the other thing is, when I check the filament voltage, again, we'll pick on this tube over here because it's easy to get to. Oops. And the voltage was ranging between 1.2 1.3 when I was checking it before. Is this the filament on this one as well? Yeah, 1.2. This one, let's see, the output tube, 1 and 7. 1 and 7. So, let's see if I can get in there without shorting anything out. There's 1, there's 7. Now that's saying 2.9. Now that tube is supposed to be 2.8. So the filament voltages overall are decent. The plate voltages are fine. So even though others told me that this was a bit too high, and I was myself expecting to be, it actually, I kind of expected a 180, 190 ohm resistor would have been what I would want to go with, but based on what I'm seeing, I'm thinking it's okay. And one of the things I did, because I was trying to get the filament voltages up, and I mentioned it before, these are both 1K ohm resistors, not 1030 ohms. And I did that on purpose because the filament voltage is more important to me than the plate voltage. So since I had a 200 ohm already in there, I was hoping that that could stay, and by using the lower ohm resistors here, that would get my filament voltage up where it belongs. And I think it's worked out fine. So I'm good to go, I think. But so bottom line, I got lucky. I think the 200 ohm is going to work just fine. These worked out really well. I think if I had gone with the higher ohm resistors, I might have gotten lower filament voltage than I really wanted. So I think I'm good to go. And we'll move on to the next part of the project. Although there's one other thing that I want to show you. And this is less than great. Yeah, okay. Alright, I don't care. The antenna's unhooked. It does not matter because we aren't going to be using the antenna. So, I'm always amazed at how fast these little radios come up. Alright, here we are. This is my 1S5. If I were wanting to use this as a musical instrument, that would be great. This is a microphonic tube. I have tried three tubes in this radio, and they all do the same thing. So again, using my Radio Club resource, I talked to some of the guys that have been around a while, and he said, one of them said, 1S5s, I think those have been problems since the day they were made. I think a 1U5 would work better. I don't have a 1U5. Okay, so here's my 1S5, and this is what I actually did to fix it. Rubber splicing tape. It looks like this. Interesting tape. When you're using it, you have to stretch it If you don't stretch it, it won't stick. So I wrapped the first layer around, and that didn't work all that great, so I wrapped the second layer around it, and that seems to have helped. We'll see how that behaves. I had another option, well, a couple of other options, a couple of other options. I could put a 1U5 in here, but that would mean I have to rewire this socket to make that tube work. Or there were some other oddball tubes that were direct replacements for this one. I don't know how easy it would be to find any of those. They were definitely oddballs. I've never heard of them. So one of the radio club members had suggested, some of the guitar amp guys use rubber bands they wrap around some of the tubes where they have problems with the tubes being microphonic. I said, well, that's an interesting thought. So then it occurred to me I've got this stuff, so I thought I would try it. The advantage of these low voltage tubes is they don't get very hot. And I don't know if these tubes were the type that get really warm, if this would be the right idea or not. Maybe rubber bands would be better, I don't know. But since these stay pretty cool, I thought I would try that, and it does seem to have calmed down the ringing that it was doing. So that may be enough to solve the problem. You might never notice once I mount the speaker here. You might not get ringing from that tube. It definitely does seem better, but we shall find out when I get it together and we actually start playing it. Okay, so ready to wrap up part 2 at this point. I mentioned in the note, I made a note saying that my repair job here did not fix this ringing problem, sadly. So that's one thing I'm going to deal with, but in testing and playing with this radio, I've discovered something that's rather frustrating. This little radio has probably been the most challenging of any of the radios I've had to work on. It's one of them anyway. The other thing I found when I started playing with this and testing it was there's distortion that's occurring on the output of this tube. And at first I thought this tube was the problem. In fact, my tube tester flaked out on me when I tested it and told me the tube was bad, so I got another tube. Turns out neither of the tubes were bad. I think there's a flaky connection, so I need to work on my tube tester. It's the trouble with dealing with old equipment. It does annoying things. So I tested the voltages, checked everything out thoroughly, and this tube may be doing more than just being microphonic. This is the 1S5 that I'm unhappy with. I've got two problems. This tube, the plate voltage is low, which could mean that the tube is conducting more than it should be. The filament voltage on this tube is too high. I'm not sure if that's related to the plate voltage problem, and I don't know if that's also causing the distortion that I'm getting out of this tube. And the distortion is volume dependent, and it's also radio station dependent, it seems. I've got a good local station. I say good, sort of. I've got a local station that is easier to receive, and it's louder, to get more power at least than any of the other stations I can pick up. And on that station, when I get the volume of a certain point, it distorts and misbehaves, and it's not something you want to listen to, unfortunately. So, my part 3, I was going to deal with how the tuning part got repaired, speaker repair, but now I've got this. So what I'm going to do for part 3 is I'm going to get another tube, a 1U5, I'm going to rewire the radio to accept the tube. And I'm also going to have to check out, before I do that though, there's one other thing I want to check, and this is, let me see if I can zoom in a little bit here. This is my 1S5 right here. So let me see if I can get that to where you can see it. Am I looking at the right tube? Yes, kind of. Alright, so there's my 1S5. Stop doing that. Okay. Alright, so here's what I'm dealing with. I'm getting 9 or 10 volts here on the plate. It should be 45 to 60. I've got someone looking at a better copy of the schematic, which hopefully gives me an accurate voltage for this, because what I have is ludicrous. It's saying 0.5, which is insane. So that clearly is not correct. So what I'm going to do, though, is I know what this tube is supposed to be drawing for current. What I'm going to do is I'm going to measure the voltage drop across this tube, and I'll use Ohm's law to figure out how much current is being drawn by the tube through the plate here. That might give me a good idea of what's going on with this tube. Now, and I don't understand why all the other 1 volt tubes, the 1.4 volt tubes, are 1.2 volts. This one is 1.6. So clearly something is going on here, and like I said, I've tried 3 different tubes in here, and I haven't seen any difference between any of them. I haven't checked the filament voltage on all of them, but I have a nasty suspicion that they're all the same. So, don't know what's going on. So, I'm wrapping up part 2 here, because I have some work to do on this before I can produce part 3. So I'm going to, like I said, I'll deal with this tube. We'll check this out. I'll show you how I repaired this. You might find that interesting. You definitely, I think, will be interested in how I repaired the speaker, which had no cone left in it. The speaker cone was in tatters. There was not much left of that speaker cone when I got this radio. So, and I just could not find a decent replacement, because this tube is, this speaker, I think, is a 5-inch rather than a 4-inch. And you want a speaker that's got the normal vintage magnet on it, because you only have so much room here. The newer speakers have this big round magnet on there. It wouldn't fit, so that's a problem. Plus they were designed for higher watts, which likely would make this radio much quieter than I want it to be. So there's that. So I finally decided to suck it up and actually repair that speaker. And so there's going to be a section in the part 3, I'm hoping. I can put that in there. That shows you how I repaired it and the end result of that repair. So, yes, this radio is unique. I think it could be a good performer once I get it all fixed. But right now, I said in the video that this seemed to be working better than my other radio, and in terms of sensitivity it seemed to be really good, but right now it's not working as well because I've got that distortion issue. So wrapping it up here, hopefully see you for part 3. I'll tell you, this little radio is definitely challenging me, and I'm going to school on this sucker, so I hope you come along with me. Thanks for watching.